We'll go for the next problem. Here we have an interesting problem which is an important from the examination point of view. If I was given an opportunity to set a question paper on parametric function, definitely I would have selected this question, because this question is very interesting and very tricky, and if you have good knowledge about parametric functions, this is a question for you. So this question definitely would have selected. Very interesting. Watch it. Here x equals to under the root a to the power of sine inverse t, and y equals under the root a to the power of cos inverse t. Show that dy by d equals to minus y by x. So here, the moment you see this problem in the examination, some of the students, I am sure they will not attempt to this problem. They just ignore it because they feel it complicated. Definitely they will not select. I will tell you at least 50 to 60% or 40 to 50% will not attempt this problem. If they are extremely intelligent who are competing for ranks, only they will prepare for such, or they will anticipate such questions in the examination. But a normal person will just ignore it. So dear students, it is very simple, you cannot ignore this. If you know what all I have taught you, like sum rule, difference rule, product rule, quotient rule, then implicit functions, parametric functions, composite functions, you should be able to do this problem. Otherwise, it is not worth that you have learnt it. So dear students, very simple. The moment I show you the technique, you definitely know it's such a simple problem, you wouldn't have attempted this. So let's do this problem. In your interest, I want to do it because I want to prepare you for such eventualities, such questions in the examination. So the problem is very simple. Let's do it. So students, here he has given x equals under the root a to the power of sine inverse t. So what is the best way to tackle this problem? So what you do is, when you get such problems, you take to the power of half. I tell you how it is. See, what is root x? Nothing but square root of x is nothing but x to the power of half. So I'll use this concept to solve this problem. So what I'll do is, can I write like this? X equals a to the power of sine inverse t to the power of half. Can I write like this? Yes, very much. So now you are able to differentiate this, because now it has come to standard form. This was not in standard form, but now it is a standard form. So I'll show you, this is of the type a to the power of x to the power of n, right, where n is half. So you can easily solve this. So here, now differentiating with respect to, this is t, we get what? See, dx by dt equals to d by dt of a to the power of sine inverse t whole to the power of half. Now you can do this. So if you differentiate, what do you get? This is nothing but, this is d by dx of x to the power of n is what? Nothing but n into x to the power of n minus 1. Done. So I'll use that concept. What happens here? This becomes half into a to the power of sine inverse t to the power of half minus 1. Half into a to the power of sine inverse t half minus 1 into d by d theta of a to the power of sine inverse t. So what is d by d to the power of? See, we have one more, that is d by dx of a to the power of x. This is of that type, a to the power of x, where x is sine inverse t. This is of this type, What is the solution for this? This is nothing but a to the power of x log a to base c, right? So I have to use that concept here. So what I'll do, I'll rub this. So what is this? This is our dx by dt. Now dx by dt equals to half we have, that is half, this is a to the power of sin inverse t to the power of half minus 1 is minus half. This becomes minus half into d by d. What is this? So this becomes what? A into sin inverse t log a to base c and d by dx of sin inverse t. See this. After doing this, again you have to differentiate that. So here let us see, for example, if you have to differentiate this, what happens? A to the, that is a to the power of log a to base c into d by dx to the power of x. This is nothing but 1. So that's the reason we are not using. But here in this case, we have to differentiate sin inverse t also. What happens here? So I'll rub this. I'll rub this too. Okay. This is that is dx by dt equals to half. I'll take outside. So this is a to the power of sin inverse t to the power of minus half into a to the power of sin inverse t log a to base c into d by dx. This will be 1 minus t square d by dx of sin inverse x equals to what? Under the root 1 minus t square. So yes, sorry, you see x square. This is the formula I am writing. So this becomes 1 minus x square. So I use that concept here. For sin inverse will be under the root d by dx 1 by under the root 1 minus t square. So I use that formula. See, formulae, wherever you go in differentiation, it will not leave you. It will follow you like a shadow. So be strong with your formulae. That's all I can advise you, not more than that. So dear students, I'll rub this. Let's solve this. This is equals to 1 by 2. I will bring this here itself. This will be 1 minus t square. I will take it outside. So this becomes a to the power of sin inverse t to the power of minus half into a to the power of sin inverse t. I will write it to the power of 1. I will take this to the power of 1, okay, into log a to base c. Okay, now here the bases are same. I will add the indices. Done. I will rub this. So bases are same. So dx by dt equals to half into 1 minus t square So what happens to this? A to the power of sin inverse t to the power of minus half plus 1 into log A to base C. I rub this. So what happens here? That is dx by dt equals to into 1 minus t square. So this becomes a to the power of sin inverse t. So this becomes half minus half plus 1 is half. You get plus half into log A to base C. I'll rub it. So what I'll do is I'll simplify this. This is half into under the root 1 minus t square. I'll write this. What is this? This is a to the power of sin inverse t. Half I'll put it as bracket. So I have taken this root x equals to x to the power of half, x to the power of half, or x to the power of half can be written as root x, right? So here we have a to the power of sin inverse t, a to the power of sin inverse t to the power of half. I can write this as a to the power of sin inverse t within root, then into log A to base C. And what is this? Half into 1 minus t square. This becomes nothing but x into log A to base C, since x equals under the root a to the power of sin inverse t. So I substitute this value as x because x equals under the root a to the power of sin inverse t. So that's the reason I replace this entire value with x. Done. So what we wanted? We wanted x, we have already got it. This is how you have to approach. Done. So what I'll do? What is x? So I'll make a note of this. Here dx by dt equals to equals to 1 by 2 into 1 minus t square into x into log A to base C. I have made a note there. I love this. Please make a note. Any doubt? Please once again cross check it. So now we will go for y. And y equals under the root a to the power of cos inverse t. Do this problem on similar grounds only. Now this will be dy by, I will write this, differentiating with respect to t, we get, I will write here, okay, and okay, so I will write this one line. So differentiation with respect to t, that is dy by, okay, I will turn this, before that I will change this, that is y equals a to the power of cos inverse t to the power half. So I removed this root, I put half. Now you can differentiate it. Differentiating with respect to t, we get what? Dy by dt equals to what? So this of the type x to the power of n. So this becomes half into, and put a bracket, a to the power of cos inverse t to the power of half minus 1 into d by dx of a to the power of cos inverse t. I'll rub this. So what happens to this? This equals to half into e to the power of cos inverse t. This becomes half minus plus half minus 1. So this becomes minus half. And what about this? This becomes a into cos inverse t log a to base e into d by dx of cos inverse t. So you have to differentiate even the inner function. So I'll rub this. Let's simplify. dy by dt equals to half e to the power cos inverse t to the power of minus half into a to the power of cos inverse t. I will write it as to the power 1. So I can write this as to the power 1 into log a to base e. Now d by dx of cos inverse t, that is d by dx of cos inverse x equals to minus 1 by under the root 1 minus x square. So remember, whenever we have something to do with c, that is cos theta, cot theta or cosecant theta, we will always have a minus value. Don't forget this. I have been telling you right from the beginning when I was doing problems on video on, that is formulae. So in class 1 I have given you a list of formulas, please go through that. So d by dx of cos inverse x is 1 minus 1 by under the root 1 minus x square. So what happens here? Into minus 1 by under the root 1 minus t square. I'll rub this. So what happens here? I'll bring this here itself. So that equals to half into 1 minus t square. So a to the power of cos inverse t to the power of minus half into a to the power of cos inverse t to the power of 1 into log a to base e. So I'll write little below, you'll get confused. So what I'll do is, this is half, I'll bring the t square here, 1 minus t square. This is a to the power cos inverse t to the power of minus half into a to the power cos inverse t. I will write it within 1. So I will write this log a to base c. Dear students, will follow this. So we have a minus value, you take that minus value here, equals to minus, what is this, dy by dt. dt. So this minus value we have, so take this minus value, this minus sign I have taken it here. I rub this, so dy by dt equals minus half into 1 minus t square. See, the bases are same, add the indices, so this becomes a to the power of cos inverse t to the power of minus half plus 1 into log a to base c. I rub this, so dy by dt equals minus half into 1 minus t square. So this becomes a to the power of cos inverse t. So minus half plus 1. So minus half plus 1 is plus half into log a to base c. I will rub this, this dy by dt equals to minus half into 1 minus t square. So this becomes what? I will write this under the root a to the power of cos inverse t, since x to the power of half equals to root x. So this half I removed it and I put this within the bracket. But what is this? A to the power of cos inverse t. A to the power of cos inverse t is nothing but your y into log a to base c. I rub this, okay, I rubbed this, sorry, I rubbed it off. Okay, so this is nothing but minus half into 1 minus t square under root a to the power of cos inverse t into log a to base c. I rub this, this is our dy by dt, isn't it? So what is this? Can I write like this? This can be written as minus half into y log a to base c, since a to the power of cos inverse t equals to y. See this, a to the power of cos inverse t is nothing but y equals a to the power of cos inverse t. So I have substituted that. So this is our dy by dt. to find dy by dx. So you are going to find dy by dx. So once you have got dx by dt and dy by dt, using chain rule we can easily find dy by dx. So by chain rule we have, I read this, we have there only, we have dy by dx equals to dy by dt by dx by dt. So what is dy by dt? dy by dt is minus, I will write like this only, minus half y into log a to base c divided by, and what is that? That is half, here we have one t square by under the root 1 minus t square y into log a to base c. So dear students, please make this correction. So here also I write this. So what is dy by dx? That is nothing but minus half into under the root 1 minus t square y into log a to base c divided by half 1 minus t square into x log a to base c. Done. So what happens here? This cancels, this and this cancels, you are left with minus y by x. I love this. So you are left with what? Minus y by x. What do you want? dy by dt minus y by x. So you got minus y by x, we already got it. So therefore dy by dx equals to minus y by x. Hence proved. Dear students, if you can do this problem independently without seeing this notes, without seeing this, so for that you need to practice, and once you have practiced, if you do this individually without anybody's support, believe me, you have learnt differentiation, because this problem involves many things. So whatever I have taught you, that will really come into play, it will help you a lot. So don't neglect any of my subtopics what I have taught you in differentiation, that is sum rule, difference rule, product rule, quotient rule, then parametric functions, implicit functions, parametric functions, composite functions. This will make you strong in differentiation. So if you are strong in differentiation, you will be strong in integration too, because same concept, formulas also more or less same thing. What only thing, for example, in differentiation d by dx or sin x is cos x, but whereas in integration of sin x will be minus cos x. So you will know little things will be changing. So dear students, this problem is really very interesting and only inspire you to do. Once you learn these problems, how to do it, you will start loving mathematics. So dear students, let us stop here, and I will try to finish part 2. If you require part 3, I have some more problems, I can do it, but I think this is more than enough. With part 1, the slight mistakes in the beginning regarding how to find a table, please make that correction, because by oversight it has happened. So if you watch the TV, video for some more time, that correction has been restored and I have done it correctly. So by oversight has happened because I did not divide it by denominator. That's the reason it has gone wrong. So please try to correct that and follow my full video, you'll get it. So dear students, this finishes part 2 of parametric functions. If you are interested, and if you in the comment box, if you write, if you want some more problems, definitely I will do it, provided you give in the comments. Otherwise, I shall stop parametric functions. I will switch on to successive differentiation because that is very important. So once I do successive differentiation, you will be prepared for partial differentiations. So we later on will see nth derivative, Leibniz theorem, all those things we will do and switch on to other topics. So dear students, I will stop here before I forget. So please share my video, like my video and subscribe to my channel. That is very, very important. Without that, I will not be motivated. So don't you think I deserve to have a subscription? I deserve and you need to subscribe to my channel because I really have put hard work in teaching to you. So students, it's your duty and it's my rights and I deserve it. Please subscribe to my channel. With this, I end parametric functions here. Only I'll be waiting for your comments. If you want, I'll do part 3. Otherwise, part 1, part 2 is sufficient. So I have tried to cover most of the important problems pertaining to examination. So most probable questions are there in this for the examination. If they give any problems on parametric functions, definitely this video will help you. So let me end here. So dear students, thank you. Good night. Take care. God bless you. Bye.